Hi, so I had a request if I could make a video about LED displays, and because they're so common and so useful in lots of different projects, that seemed like a pretty good idea. So here it is. So I've set up on the board a variety of different sorts of LED displays. So starting at the top, I have just a simple LED on its own. I've then got a 7-segment LED display. This one here is a 4-digit 7-segment LED display, and finally I've got an 8-digit 4-segment LED display. So they're kind of working from top to bottom. They get sort of increasingly more complex. So I thought I'd start at the top and work my way down and just cover off some of the different things that it's useful to know on the way down. So starting off with the simple LED. You probably know this already, but just in case, I thought I'd cover the basics. So there's two important things to know about an LED. The first thing is it's a light emitting diode, and like all diodes, that means that current can only flow in one direction. So if I just pop that LED out for a minute, and you'll see it has 2 legs. One leg is longer than the other one. So I always have this problem trying to focus on things too close to my camera. So the longer leg is the anode, and that gets connected to the positive voltage supply. So if you're wiring to an Arduino, that would normally be plus 5 volts. The shorter leg is the cathode, and that gets connected normally to ground. So you've got 5 volts across the legs from the anode to the cathode, and that's what makes it light up. That's the first important thing. If I plug that back in the wrong way round, like that, nothing will happen. And if I turn it back round again, you'll see it lights up. Okay, so the second important thing about the LED example here is this little resistor at the top here. So, generally speaking, you don't want to wire an LED straight between 5 volts and ground on your Arduino. That will supply too much current to the LED, and the LED might light up very brightly for a while, and then it will probably burn out. So what you need to do, normally speaking, is to always place a resistor in series in the circuit. So on a simple circuit like this, it doesn't actually matter what side of the LED it goes. You can put it between the anode and the positive supply, or you can put it between the cathode and ground. It doesn't matter, and it doesn't matter which way you put the resistor in either. The only thing you need to do is to calculate the right resistance value. So to do that, what you do is you take your input voltage. So I'm supplying 5 volts input here. You find out the forward voltage across the LED. Different coloured LEDs have different characteristics. It will normally be printed on the data sheet that comes with the LED, but if you can't find that, you can make an approximate guess based on the colour and look up online. So this LED has a forward voltage of 2 volts. So I'm supplying 5 volts. This has a forward voltage of 2 volts. You work out the difference between them. That's 3 volts. And then what you need to know is what's called the forward current across the LED. And for this one, it's about 20 milliamps. So you've got your voltage drop of 3 volts. You divide that by the current, the forward current you want, which is 0.02 amps, and you end up with a value for the resistor. So if I just plug that into my calculator, I get 3 volts divided by 0.02 would give me a resistor value of 150. Now I didn't actually have a 150 ohm resistor to hand, so what I've done is I've gone for the next higher one up, which is 220. All that means is that the LED is going to be slightly dimmer than it could be optimal, but it won't do any harm, and it will make the LED last for longer. Okay, so that's a simple example of the LED. Now we move on to the next more complicated one up, which is the LED 7-segment display. Now, this essentially, what you're looking at here is 7 individual LEDs, just like the one up here, but they've been arranged in the segment shape here so that you can make different digits and some characters as well. So, unsurprisingly, as you might expect, every one of those LEDs is individually addressed. So I need to have 7 wires going into it. So I've got 3 at the bottom and I've got 4 at the top there. and they also have a common wire that's shared between all the LEDs. Now this is where it gets slightly complicated. You're probably familiar with, on a circuit like this, you can have lots of components all going to ground and they share a common ground. Or you can have lots of components running off the 5-volt rail as well, and they all share a common 5-volt. And it's exactly the same with a 7-digit display, a 7-segment display like this. There's two sorts. You can get one that's called a common cathode 7-segment display, and you can also get one that's a common anode 7-segment display. If you remember what I said about the LED, so if it's a common anode, which is what this one is here, I've got a 5-volt input at the top, which is shared between all of the different LED segments, and then each of these individual wires, if I want to light that segment up, I set that to ground, or I do a digital write low effectively, which is the same thing. If it was a common cathode instead, what I'd be doing here is this center pin here would be ground, and then each of these cables here, if I wanted to light the corresponding segment up, I'd send a digital write high. So it's the same, effectively the same wiring internally, it's just everything's been reversed. You're either sending a high signal, which goes down a common ground, or there's a common source of 5 volts and you're sending individual grounds for the signal to go through. So it's just the current flows in different way through the LED segments. Okay, now we move on to the 4-digit display. So we're getting a bit more useful now because you can actually do slightly more when you've got more digits available to you. So it might have become obvious that if you simply put 4 of these in a row, you're going to have quite a job wiring it and controlling it, because each of these, just one digit like this, is going to require 7 cables for each of the 7 segments, and also the common pin as well. So if you're trying to wire 4 like this, you think, well, that's going to be 28 leads, which is going to be rather a nightmare to wire. Fortunately, however, there's a solution to this. When you look at a module like this, it generally has a controller chip in it as well. And there's a couple of different controller chips. I'm just trying to take that off the board, and I will show you on the back. So on the back of this circuit board here, this little integrated circuit at the top here, so this is a TM1637 module on the back here. And that's a very common module which is used to control just 4-digit segment displays like this. I'm going to screw that back on. And when you're using a TM1637, you don't actually have this mess of wires. It becomes simpler wiring, if anything. You simply have 4 wires. The black and the red cables here are my ground and my 3.3 voltage input on this one actually. That's another point worth checking. Most modules like this are tolerant to either having a 3.3 volt supply or a 5 volt supply, and they'll adapt depending on whichever one you use. But it is worth checking, because I blew one of these up supplying 5 volts when I actually wanted 3.3. I think there are some that are more tolerant, but always check the datasheet of whichever module you're using just to make sure what the supply voltage is. So I'm wired to 3.3 volts on the red cable, ground on the black, and then there's 2 pins here which are for a data line input and for a clock input. So rather than individually controlling all the segments here, what we're now going to do is we're going to send pulse signals to that controller on the back, and that is going to translate it into which segment you want lit to display a particular character or number and things like that. Now the software side gets a little bit more complicated than these examples. Here, to control the single LED or the segments here, you're basically just using digital write high and low and the pin of the segment or the LED that you want to light. Here, it's getting a little bit more complicated because we're actually interfacing with that chip on the back. So you need to use a library. Now fortunately, there's lots of libraries readily available for all these modules already, so I'll show you the code I use to control this one. And as I said, there's several different controller chips, and each controller chip comes with a different library as well. So here, for the 8-digit 7-segment display, This has got a different sort of controller on it. This is called the MAX 7219, and that controls 8 digits like this in a line, and the controller can also be used to control an 8x8 sort of grid of LEDs as well, the same controller. And this one has 5 pins. So again, voltage and ground. So this one is a 5-volt display, so I've got the 5-volt plugged in here. And then it has a data in, a clock, and a select pin as well, which are just wired to my digital outputs there. And just like in the 4-digit display, each one of these characters can be individually controllable to display a number or text. So in a strange way, although these modules at the bottom are more complex in some ways, and they're certainly more flexible of what they're able to display, the hardware is actually much simpler. You either need 5 wires or 4 wires in this case, and you don't need to bother with the individual resistors on each of the LED segments anymore, because that's all integrated into the back of the module here as well. So the wiring becomes much simpler. And the code is actually not too bad either. So let me show you the code for these examples. So we'll have a look at the code first of all for the 4-digit display, which is using the TM1637 controller on the back. So I'm using this library, which I got from GitHub. You can go to this link and download it. And when you've downloaded the library and installed it into your Arduino libraries project, you then just need to include the library in your code from this line here. So I'm defining 2 constants here, and I'm defining one called off, which is an array that just has zeros in it, 4 zeros, and I'm defining another constant called play, and that's got 4 binary values in it, and those binary values represent the segments that I want to turn on to spell the word play. So each one of these zeros and ones corresponds to one of the 7 segments in the display, and there's actually an 8th segment as well. That's for the decimal point, but I never use the decimal point, so that's always 0 in all of these letters here. And then the order of the remaining ones and zeros show which of the segments I want to display, and they're lettered A, B, C, D, E, F and G. And in this library at least, they're actually listed in reverse order. So if you take a look at this diagram here, this is the lettering convention that's normally used to refer to all of the segments on a 7-segment display. To spell the letter P, the segments I'm going to want to turn on are A, B, not C or D, but then I do want to turn on E, F and G. So when you make the number 1 represent on and 0 be off, if you write those ons and offs in the order A, B, C, D, E backwards like this, this is the pattern you get. So that there is a 1-byte representation of the letter P. If we then go on to look at the letter L instead, so the letter L, I don't want A or B or C lit, but I do want D, E and F and not G. So again, counting backwards on this thing here, we've got A is 0, B is 0, C is 0, and then D, E, F are 1s, and G and the decimal point are both zeros. And you can extend that not just to letters or numbers or any pattern at all you want to represent using those 7 digits. So that's just a way of representing it. So I'm going to define that a constant at the start of my code, so that from then on, when I want to display the word play, it's going to represent those 4-byte values to correspond to the letters. On this line here, this is where I'm actually initializing the display itself, and as I said, for the TM1637 you need a voltage supply, which I'm using 3.3 volts for my Arduino, a ground, and then 2 pins, one for a clock signal and one for a data signal. So I'm using a clock attached to 2 and a data on pin 3. That's it. You don't need to explicitly set those as outputs within your setup program, because that will be taken care of by the library itself. So in setup, I'm just going to set the brightness. That can be a value from 0 up to 16, so represented by 0x0f, but I'm using C, which is a little bit low, the maximum brightness there, just to save a little bit of power, and also because it's glaringly bright if you're on maximum brightness. And at the start of the code, at least, I'm going to call this set segments function, and you pass an array of values for what you want each of the 4 segments to represent. Now I'm passing off, and remember at the top of my code I defined off to just be 0, 0, 0, 0. So every segment of every digit I'm going to turn off at the start. Okay. And in my loop function, I'm just calling 2 different codes. I'm just alternating between these 2 functions just to demonstrate 2 different ways of using it, really. In the first one, I got display text, and just like when I set the segments to off, here I'm setting segments to play, which was my array that represented the 4 different letters P, L, A, and Y. And I'm going to display that for 2 seconds, and then I'm going to go on to countdown, and countdown is here, and this is just a loop that counts backwards from 5,000 down to 0, and I'm going to use the show number dec function from the library. So I'm going to show the number I, so whatever the counter value has got down to at the moment. True, this function here allows you to insert leading zeros. So if I'm down to a single digit number at the end, but I'm still trying to fill 4 decimal places, not 4 decimal, 4 digits, sorry, this will insert padded zeros at the beginning. I'm filling all 4 of the digits, and I want to start at the 0th one. So that just loops down my counter values, filling all of the places, inserting leading zeros if necessary, and then it just waits 80 milliseconds before showing the next value. And so that is all my code is doing. It's quite a simple one. Now if we take a look at the code for the 8-digit 7-segment controller, and remember this was running a Max 7219 controller instead, so it's a different controller powering it, and that means that I'm using a different library as well. So here's the library I'm using in this case. Again, you can download it from GitHub, and when you've got it downloaded and extracted, you simply incorporate it in your Arduino project using a single line like this, and this is the library. So there are some elements that are very similar to with the TM1637 library, and there's some elements that are a bit different. So to start with, we define a display just as we did before, but this time we've got slightly different parameters that we have to supply. So there's 3 pins that we are using to connect to the Arduino. It's the data pin, which I'm using pin 2, the clock pin, which is going to 4, the select pin, which is going to 3, and then this last parameter here is the number of displays you're using. It's possible to daisy chain together lots and lots of Max controllers all together, you see. Now I'm using 2 side by side, so I want 2. Now this bit here, this is very similar to how I was defining the constants in the last code. The only slightly annoying thing is that they use a different byte ordering format. So in this library, the segments are listed perhaps in a more conventional order, decimal point first, and then A, B, C, D, E, F, G. If you recall, if I go back to the other script briefly, I was having G, F, E, D, C, B, A. So I'm having to redefine the letters, and also because I've got a bigger display to play with here, I'm actually using slightly longer words than I was doing before, can make use of the longer display. Setup, very similar to before. We're going to wake the display up. So this controller is a bit more advanced than the TM1637, and it actually has a sort of a power down function, which is the mode it comes on as when it's first initialized. So the first thing we're going to do is wake the display up out of its power down mode, which we do by sending a false signal to shut down. We'll then set the intensity of the display. I think the display on this one goes between 0 and either 7 or 8, I can't remember. So again, this is a little bit off the maximum brightness just to save a bit of power. And then we'll start off again by clearing the display out. This time round, rather than having to define a sort of 0 values, there's actually a function called clear display as part of the library, so I can just call that to send zeros to all the segments. And again, as before, in my loop, I'm just looping between two different functions, display text and countdown, although the actual way in which they work is slightly different than in the previous example. So with the other library, I passed an array of all 4 characters to be displayed at the same time. In this library, I'm calling the setRow function, which actually only sets the segments on a single digit at a time. So because I'm doing that, I thought I'd actually spell the letters out one at a time with a short delay between each anyway. So I'm going to loop through all 7 characters in the word playful, and I'm going to call the setRow function starting at the 0th row and the 7th character back. So this is a bit confusing, but the character on the furthest right of the display is got the index 0, and then the one back from that is 1, 2, 3, 4, 5, 6, 7, etc. So if I want to start at the beginning, at the left-hand edge, I'm going to start at digit 7, and then as I increases, so as I count through the letters of the word I'm going to spell, this number actually gets smaller, closer to 0, because that's going to be the right-handmost character, is going to be 0. So I'm going to display the character which was defined up here in the appropriate position on the display with a short break in between each letter, hold that for 2 seconds, clear the display, and then I'm going to spell my next word. So that's my text test, and then after that I do the countdown test. And again, this works a little bit differently. Whereas the last library had a function that you could just pass in a number and it would put the correct digits in the correct position on the display, this one you manually set each digit in the display. So I've got my units column. So I'm starting with a large value here, and I'm counting down. I'm counting down in units of 60 just to make it count down a bit quicker. That's the only reason for that, really. So the 0th digit, remember that's the one going to be at the right handmost end, that is going to be my units column, and then I'm going to display my tens column, and then my hundreds, my thousands, my 10,000s, my 100,000. So I'm simply dividing each one and then taking the modulo of 10 just to get the remainder, and that's going to give me my nice countdown. Delay 10 milliseconds in between each one, then clear it and go back to the other one again. So that's about all there is to say about LEDs and LED displays, really. So just to summarise, obviously make sure your LEDs are plugged in the right way around. Always use a resistor of the right value. If you're using a segment display like this, check the voltage requirements of the module, whether it's 3.3 volts or 5 volts, or whether you can use either, and plug the pins in correct, and then you just simply have to use the library for the controller pin on the back. So I hope you found that useful, and thanks very much for watching.